Hi Year 11, today we're looking at lesson 3.11, quadratic identities. So our syllabus dot points are to use the fact that two quadratic functions are equal for all values of x if and only if the corresponding coefficients are equal to solve related problems, and we're going to find the equation of a parabola given sufficient features. Your learning intention today is to solve problems involving quadratic identities and to find the equation of a parabola. You'll feel successful if you can perform algebraic expansions to equate the coefficients of a quadratic function to a quadratic identity, if you can form and solve up to 3 equations simultaneously to solve problems related to a quadratic identities, and if you can find the equation of a parabola from given information or a diagram. Today we're just going to focus on the identity of quadratic expressions. So if two quadratic functions are equal for all values of x, then they are identical and their corresponding coefficients must be equal. So if we have, for example, ax squared plus bx plus c and dx squared plus ex plus f are equal for all values of x, that means we want to equate the corresponding coefficients. So our coefficients of our x squared are our a and our d, so that means they are equal. Our coefficients of our x are our b and our e, so they are equal. And finally, our constant terms are c and f, so they are equal. So in our first example here, we want to write 2x squared minus 3x plus 5 in the form of a lots of x minus 1 all squared plus b lots of x minus 1 plus c. So what we're going to do is we're going to grab this form that we want to write in, our a, I'll do a capital A, our a lots of x minus 1 all squared plus our b lots of x minus 1 plus our c, and we're going to expand this. So our first bracket, our x minus 1 all squared, is a perfect square. So we're going to have a lots of x squared minus 2x plus 1 by expanding our perfect square. Remember, with perfect squares, we have a minus b all squared is equal to a squared minus 2ab plus b squared. That's how I did that so quickly. I'm then going to expand our bracket with our b lots of x minus 1. So we'll have bx minus b, and then we just have our plus c. I'm now going to expand in my a, so I'll have ax squared minus 2ax plus a plus b of x minus b plus c. What I'm going to do now is I'm going to collect my terms. So what I mean by that is I'm going to write my ax squared first, and then I'm going to collect all my terms that just have coefficients of x. So I'm going to have plus my minus 2a plus b lots of x. Okay, so collecting all my x terms together, and then I'm going to collect all my constants together, which is my a minus b plus c. Okay, what I'm going to do from there is I'm going to let my 2x squared minus 3x plus 5 equal that ax squared plus minus 2a plus b lots of x plus my a minus b plus c. From here, I want to equate my corresponding coefficients. So the same as how I highlighted my letters up the top, I want to equate my corresponding coefficients. So I want my x squared to be together, my x's, and my constant terms. So what this means is we have that a is equal to 2 because they are our coefficients of our x squared. We're going to call this 1. We then have that minus 2a plus b is equal to minus 3 because they are our coefficients of x. And then we have that, and we're going to call that number 2. And then what we have is a minus b plus c is equal to our constant term of 5. Oops, that's meant to be green. So what we want to do from here is call that equation 3. Now we know what A is, so we are going to sub A equals 2 into our equation 2 in order to solve for B. So what we will have is minus 2 lots of A plus B equals minus 3. Oh, instead of the A, I meant to have written a 2. Whoops, whoops, whoops. Hopefully you guys picked that up. Okay, this is then minus 4 plus B equals minus 3. We're trying to solve for B, so we need to plus the 4 to the other side. So we get that B is equal to 1. Okay, now that we know what A is and what B is, we want to sub A equals 2, B equals 1 into 3. So what we will have is we'll have our 2 minus our 1 plus our C equals 5. So we have 2 minus 1, oops, I don't need to write that out again, is just 1 plus C equals 5. We're then going to minus the 1 from both sides to get C equals 4. This therefore means that our 2x squared minus 3x plus 5 is equal to our A value of 2 lots of our x minus 1 all squared plus our B value of 1, which I'm not going to write, x minus 1 plus our C value of 4. So we have therefore written our 2x squared minus 3x plus 5 in the form of our A lots of x minus 1 squared plus B lots of x minus 1 plus C, just replacing our A, B and C with A equals 2, B equals 1 and C equals 4. Moving on to our next example. In our next example, we want to find the values for A, B and C if x squared minus x is equal to A lots of x plus 3 all squared plus bx plus C minus 1. So again, we're going to do exactly what we just did. We're going to write out our A lots of x plus 3 all squared plus our bx plus C minus 1, and we're going to expand this. So again, we have x plus 3 all squared, which is our perfect square, but this time it's A plus B all squared is equal to A squared plus 2AB plus B squared. So this will be A lots of x squared plus 6x plus 9 plus our bx plus our C minus our 1. This then equals our ax squared plus 6ax plus 9a plus bx plus C minus 1. From here, we want to again rearrange so that all of our x squareds are together, our x's and our constant terms. So we'll have our ax squared plus our 6a plus b lots of x plus our 9a plus c, and our minus 1 is classified as a constant term. From here, we want to let x squared minus x equal our ax squared plus our 6a plus b lots of x plus our 9a plus c minus 1. And we are then going to, same as above, equate our coefficients. Equate our coefficients. Equate our corresponding coefficients. I just left out the word corresponding, but that's okay. Okay, so what we have is our A value is equal to 1 here. So A equals 1. We're going to call that equation 1. Then what we have is our 6a plus b is equal to negative 1. 6a plus b equals negative 1. Call that equation 2. And then we have our 9a plus c minus 1 is equal to nothing, which is 0. So 9a plus c minus 1 is equal to 0. And we call that equation 3. from here, we know A, we want to find B, and we want to find C. So we are going to sub our A equals 1 into equation 2. This leaves us with 6 lots of 1 plus B equals -1. So we will have 6 plus B equals -1, and then we are going to minus 6 from both sides, resulting in B equaling -7. Now, looking at our third equation, we have 9A plus C minus 1 equals 0. So in order to find our C value, which is our missing value, we just need to sub in A equals 1 into 3, because there's no B value there, so we don't need to sub it in. We'll have 9 lots of 1 plus C minus 1 equals 0. So 9 plus C minus 1 equals 0. 9 minus 1 is 8, plus our C equals 0. We then minus our 8 to the other side to leave us with C equals -8. This therefore means that A equals 1, B equals -7, and C equals -8. And for this question, we were just asked to find the values for A, B, and C. So we want to make sure that we've stated those values at the end, and that's how we can answer our question.